Good morning, guys. Happy Straight Line Tuesday. Today we're going to be doing probability again. So we'll be looking at different combinations. How can I make different combinations of ice cream cones or shirts and socks and shoes? And what happens if I roll a dice and flip a coin? Things like that. So we want to start off with factorials. And a factorial is the product of a whole number and every whole number before it, except 0. So for example, 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the reason why we don't include 0, the reason why I've got this exception, well, what's 0 times anything? Well, that would just be 0. So that would mean every factorial is 0. Then why would we waste our time studying this? So 4 factorial, similarly, would be 4 times 3 times 2 times 1. And we're going to see where this comes in handy here in a minute. So what we're going to do here is start with some combinations. So I've got 3 paint colors to choose from, 2 interior colors, and 2 types of wheels. I'm going to go back to my shirt example that I did yesterday. So let's say I have 2 shirts and 3 pants. 3 pairs of pants. Well, I could have shirt 1 or shirt 2. I could pick that out for the day. And then from that, I could have pants 1, pants 2, or pants 3. So we can see pretty quickly here that I have 6 options. And the way that I would get that is 2 times 3. So I'm going to multiply all of my options together. So here I've got 3 paint colors, 2 interior colors, and 2 types of wheels. Then I'll take 3 times 2 is 6, times 2 is 12 cars. There could be 12 distinct cars if those are my only options. And you'll see that it does add up pretty quickly. So let's see, I've got 2 hats, 8 shirts, 3 pairs of pants, and 20 pairs of shoes. So a lot of shoes, not a whole lot of anything else. So what I'll do here is I will multiply all of these numbers together. So I'll take 2 times 8 times 3 times 20. I'll just type that into a calculator. So let's see, 2 times 8 times 3 times 20 would be 960. So I could have 960 outfits. And, most of the difference there are shoes. But it still counts. All right, now let's talk about some digits followed by letters, or letters followed by digits. And what I'm trying to get at here is, maybe I've got a lockbox or a combination where I've got to pick from some number of letters, and then after the letters, I've just got numbers. When I was a kid, my dad worked in real estate for a very short period of time, I remember having to go through every single combination manually when he forgot his combination once. So I've got a pretty visceral imagination of what that's like. Imagine maybe you forget your bike combination. You could spend days going through every single possible combination. So I've got one letter followed by 3 digits. Well, how many letters are in my alphabet? I have 26 to choose from. And then how many digits? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So 10 possible choices here. And my combination could be A0, 0, 0. Or it could be A1, 1, 1, or A7, 7, 7. So I've got 10 options for this first number, that first digit. I have 10 options for the second digit, and I have 10 options for the third digit, because they could all be the same. I'm not restricted in any way. So the number of possible combinations would be 26 times 10 times 10 times 10, which would be 26 times 10 times 10 times 10, or 26,000 combinations. Now, what if I said my password is 3 digits followed by 2 letters? Well, same thing. I've got 10 possible digits and 2 spaces, 26 letter options. So we've got 10 times 10 times 10 times 26 times 26, which is 676,000 passwords. So from here, you can get a better understanding of why they always want you to do more letters in your passwords. And if you increase this to include uppercase and lowercase, well, then you've got 52 times 52, which would be 2704000. Yeah, that's 2.7 million combinations, which is why a case-sensitive password, or a password where capitalization matters, makes a big difference. You go from 600,000 to almost 3 million. All right, now let's talk about rolling dice and flipping coins. So what's the probability of flipping a heads? That's 1/2. What's the probability of flipping tails? Well, that's 1/2. Okay, now let's talk about rolling different numbers on a dice, or on a die. What are my options? I've got 1, 2, 3, 4, 5, and 6. Those are my options. So I've got 6 possible outcomes. What's the probability of rolling a 2? That's 1 option out of 6. So I'll multiply these together to get 1 over 12. And here, let's talk about what's the probability of rolling an even number. Well, I could roll a 2, a 4, or a 6. So these are my even number possibilities. So that's 3 options out of 6, which would be 3 out of 12. And if I simplify that, that's 1/4. Alright, now let's talk about rolling a number smaller than 3. So what numbers could I roll that are smaller than 3? I could roll a 2 or a 1. So that's 2 options out of 6. And if I multiply 1/2 times 2/6,